Okay, ladies and gentlemen, let's talk about conditional or conditional statements. Now, conditional statements are also known as if-then statements. The reason they're known as if-then statements is whether they say if-then or whether those if-thens are implied. What you're doing is you're connecting two various statements. And normally it's in this phrase of if P, then Q. And what this implies is if P is true, then Q is true. Now, another way to write this is P arrow Q. Writing P arrow Q implies if P, then Q. Now, let's go do some in words. If it is ice cream, then I like it. Now, you'll notice there's the if, and there is the then. Well, there's basically two parts to this. One is called the hypothesis. In our case, it is ice cream is the hypothesis. The hypothesis is where everything starts. If we assume that this is true, then this must be true. This is the conclusion. So this would be P, this would be Q. The if then is implied by the arrow. So if P, then Q. If it is ice cream, then I like it. You'll notice the if and the then are not part of the hypothesis. If you put if or if you put then in the hypothesis and the conclusion, you will be wrong. So do not do that. If and then are not included, only the hypothesis and the conclusion. Now, this is another more algebraic look at things. And in this case, we have if 3x plus 2 equals 5, then x equals 1. Well, the hypothesis would be 3x plus 2 equals 5. The conclusion would be x equals 1. So hypothesis, conclusion, P, then Q. Okay, so this is the basic form for conditionals. Now, we have some related things. We have what's called a converse. Now, a converse is instead of if P then Q, like the original statement, so a conditional is P then Q, a converse is Q then P. So in our case, we would say if x equals 1, then 3x plus 2 equals 5. Now, this is a true statement. However, you'll notice if I start with this, I am guaranteed to get x equals 1. If this is true, then I guarantee this is true. However, if I turn it around, that's not necessarily true because x equals 1 is not guaranteed to have come from here. I could have said 2x equals 2. So if x equals 1, then 2x equals 2. I could have had infinite number of options, but in this case, when you turn them around, it is not necessarily just as true as the original. Now that's converse by simply switching the P and the Q. The inverse is a little different. The inverse is where I take the P, I take the Q, they're still in the same order, P then Q, but you put negations in there, the nots. So you'd say if not 3x plus 2 equals 5, then x does not equal 1. Now, here's the other problem with this. Just because it's not 3x plus 2 equals 5 doesn't mean x can't equal 1. So again, the inverse is not necessarily the same truth value as the original. But whereas the converse switches the terms, the inverse simply turns both negative in the same order. Finally, we have the contrapositive. The contrapositive is you not just do P and Q, you switch them, and you put the negation. So it's like converse and inverse together make not Q, then not P. So if not x equals 1, then not 3x plus 2 equals 5. So in this case, the contrapositive both switches them and makes them negative. The contrapositive will always match a conditional. It will always match the conditional. So if the conditional is true, the contrapositive is true. If the conditional is false, the contrapositive is false, and vice versa. Now, there is one other type of conditional that we need to talk about, and that is actually a biconditional. And that is P arrow Q, but then we also put an arrow going the other way. What this means is that if P is true, Q is true, and if Q is true, P is true. So it means that if it is ice cream, then I like it. It also means that if I like it, then it is ice cream. You can turn them around and they're both equally true. The other way to say this is the phrase if and only if. If and only if. It is ice cream if and only if I like it. It is ice cream if and only if I like it. So a couple conditionals to start with. Take it from there.